My project was to make an electrocardiogram out of an Arduino and use suction cups that have a detachable pump on them for mobility. And my working design will be shown. So for the suction cups, I decided we originally had these, and they were okay. You can kind of just take it like that and then squeeze it, let go, and then it stays on there pretty good. But these bulbs are very bulky, so we wanted to reduce as much bulk as we could. So a prototype, very hastily made, we added a foot valve to this electrode. And in order to apply the suction, we made a hand pump out of a gas siphon, where you squeeze it. It uses an 1/8 inch tube. So with the detachable pump and the electrode over here, we have the foot valve attached to the tubing. Whenever I put it on my skin and squeeze and release, let it hold for just a second, pull off the barb, and there we go. It's pretty well on there. It doesn't come off that easily, but it takes a little bit of force to take. Another great thing about these electrodes is that they have this little screw here with the hole. It's on the side here. You can kind of see that it's open. You can put an RCA cable jack in that little hole, and that is good for using as a lead. You just got to unscrew the screw and then screw it back in a little bit after pushing in the RCA cable, and you got yourself a lead. It looks pretty good, works pretty well. The suction cup works pretty well. It stays on there, and that goes into the circuit, which I'll be showing. So we also have the amplifier circuit that is basically the entire ECG. It has 3 inputs, which I have RCA jacks that I have modified to go into this cardboard, and then it goes into the cardboard into some jumpers that go onto the circuit. The circuit consists of a 741 op amp and a 9-volt battery up here, and whenever plugged in, it will take these inputs and differentially amplify them the way an ECG does, and then it will output right over here. This resistor on this side on pin 6 of the 741 is very important. This basically sets the gain so it's big enough and more visible on the scope. It's kind of hard to see since these are such small signals coming from the heart. Then we have this capacitor that comes out. It decouples a lot of the DC from the waveform so that we can have basically just a centered at 0 volts or close enough wave that goes to this yellow wire, which will go to the Arduino for the oscilloscope. And then this other end will go to the negative side of the oscilloscope or ground, and that's how that works. It works pretty well. This is called a Zytoscope. It is an Arduino application that will measure voltage, and it's basically an oscilloscope. And what it does is it uses the analog in pins. There are 6 of them on the Arduino. That has a 10-bit analog to digital converter. That this will show what between 0 and 5 volts, a 10-bit number that represents a voltage from 0 to 5 volts. And it measures on these pins. So right here we have the COM port that we're going to use. I believe it's COM4 for my Arduino. I want to use analog pin 0 because that just works well normally. And then we have ground set up to the negative terminal of the battery on the circuit. So now if I connect everything up and turn on the connection. So as you can see, it's starting to get readings, but there's a lot of noise. That can be filtered out through software. hardware filters aren't working with the Arduino because of the high capacitance that's needed, or the high resistance that's needed for a low pass filter. So what I'm going to do is I'm going to hit record and go for about, let's say, 15 seconds. Okay, so that was about 15 seconds. That recorded to a CSV file, which I can then access by going into where it is. And this is what the data looks like after filtering. Some final remarks. The suction cups are good for use in small periods of time. They can be kind of uncomfortable to wear. So in the future, it would be great to design some cups that are a little bit softer and not metal. Maybe still have the conductivity. Well, they need to have the conductivity to be able to get a signal. And then if they could be like plastic or some kind of other material that would stick really well, but like would still use an external pump, that'd be great. The op amp should probably be revised. It's a little bit wonky sometimes. 741s are kind of notoriously a little bit janky sometimes, but that's all fine for just the scope of this experiment. I really appreciate all the help from everyone, and thanks for watching, everyone, and goodbye.